Okay, welcome to chapter 13, section 1. We got work, power, and machines. So let's move along right into key ideas or questions here. So first off, how is work calculated, and for that matter, what work is? What is the relationship between work and power? How do machines make work easier? So, what is work, and how is work calculated? Work is calculated by multiplying the force of the object by the distance over which the object is applied. So work is force times distance. So the basic definition of work is it's the force that you apply to an object by times the distance that object moves. It's basically putting energy into the system or into the object, and as you're doing so, you're moving the object, giving it energy to move. So the force must be applied in the direction of the object's motion. So generally, whatever way you're pushing the object, that force going in that direction, that's the direction that you measure the distance in as well. So you'll get work is force times distance. So work is the transfer of energy to an object by an application of a force that causes that object to move in the direction of the force. So you're just transferring energy to that object to move it somehow by force. So work is zero if an object's not moving at all. Even if you can even be applying a force to an object, if it doesn't move, you haven't done any work on the object. Work is measured in units called joules, abbreviated with a capital J, and something called a Newton meter, which is a Newton times a meter, which goes back to the work equation. Work is equal to force times distance. Force measured in newtons, distance measured in meters. So Newton times meters gives you a joule, a unit of energy. Alright, so let's listen to this visual concept here about work.
While it may seem like work to push a car, in science no real work is done unless the car moves. Work is done when a person picks up a suitcase because the suitcase moves in the same direction as the force. Work is calculated by multiplying the force by the distance over which the force acts. However, a person carrying the same suitcase through an airport is not doing work. This is because the suitcase is not moving in the direction that the force is being applied to the suitcase. The suitcase is moving in a horizontal direction, but the force applied to the suitcase is in a vertical direction. A quantity of work can either be positive or negative, depending on whether the motion and the force are in the same or opposite directions. This toy car is moving to the right. A force applied to the left results in negative work done to the car. A force applied to the right results in positive work done to the car.
Alrighty, so you can have positive or negative work there. Depends on which direction it's going and which way the force is applied. So math skills, work. Imagine a father playing with his daughter by lifting her repeatedly in the air. How much work does he do with each lift if he lifts her 2 meters and exerts an average force of 190 newtons? So let's do given and unknowns. First off, we have force. He exerts a force of 190 newtons on her, which is basically the same as her weight. She would weigh 190 newtons, so he's picking her up by overcoming her weight. And then the distance he moves her is 2 meters in the vertical direction. So what is the work that he does each time he lifts her? Write the equation for work. So work is equal to force times distance, or W is equal to F times D. Insert the known values into the equation. So 190 newtons for force, 2 meters for the distance. You multiply those two together, you get 380 newton meters, which is the same thing we said just a minute ago as a joule, so your answer is 380 joules. Alright, so next on to power, and power is related to work. So what's the relationship between this work and power? Power is the rate at which work's done, or how much work is done in a given amount of time. So you're doing work, you're doing it over a period of time. Power is that how much work are you doing over, like each second. So power is equal to work divided by time, or P is equal to W over T, work divided by time there. Power is a quantity that measures the rate at which work done. It's just saying how much work are you putting out in a certain amount of time, or it's like each second or each hour, something like that. It's measured in something called watts, abbreviated with a capital W. 1 watt is a joule per second, which is work divided by time. Work in joules, time in seconds. So joule per second, that's a watt. And we have here a visual concept that's going to talk to us about power. So let's listen and watch.
Power is a measure of the work done, or the energy transformed, per unit time. Power is the rate at which work is done, or energy is expended. It is measured in joules per second, which are known as watts.
So if you notice there, they did 24 joules of work on moving the box from the right to the left. But the time intervals for which they did that was different. One was done with 2 seconds in time. So if you had 24 joules divided by 2 seconds, that gives you 12, so 12 watts. Then they went down to, they did it in 1 second. So that's 24 joules per second, which is 24 watts. Or they pushed the box across in only a half a second with the same amount of work put into it, because it's the same force and same distance. So then the 24 divided by half a second gives you 48 watts. So the time really plays a part there in how much power is being done. Alright, so math skills. Lifting an elevator 18 meters takes 100 kilojoules of work, because it's in joules here. If doing so takes 20 seconds, what's the average power of the elevator during the process? Now, one thing to remember here in this is in kilojoules. If you remember from metrics or from metric conversions, kilo means thousands. So what this really means is 100,000 joules, because the K stands for kilo. Alright, so list the given and known values. So work is 100 kilojoules, or 1 times 10 to the 5th joules, which is the same thing as 100,000 joules. The time is 20 seconds. In this case, distance is not needed because we're not having to figure for work. We already have it given to us. Actually it tells us that it has 18 meters, but we don't need that because the work's already given. So the unknown is power here. That's what we've got to find in watts. So we write the equation, then insert the known values into the equation. So power is work divided by time. The work was 100,000 joules, or 1 times 10 to the 5th joules, divided by 20 seconds, which gives you 5 times 10 to the 3rd, which is 5,000 joules per second. Or in this case, joules per second is a watt, so 5 times 10 to the 3rd watts, or 5,000 watts. Remember, 1,000 is kilo, so you could just shorten it up to 5 kilowatts, which means 5,000 watts. Okay, so machines and mechanical advantage. So how do machines make work easier? Machines help us do work by changing the size of the input force that's needed, the direction of the force, or it changes both. So mechanical advantage is important ratio. Mechanical advantage is a quantity that expresses how much a machine multiplies our force or distance. So mechanical advantage is the output force divided by the input force. And that's also equal to, mechanical advantage is also equal to input distance over output distance. So you have output force, which is how much force that the machine puts out. The input force is how much you put into it, so it multiplies your force. But distance, you like a ramp, you would put a lot of distances and the ramp would only move up an object so much. So mechanical advantage. Let's calculate the mechanical advantage of a ramp. It's 5 meters long and 1.5 meters high. You push the object along the 5 meters, which is along the ramp and up. So that's your input distance for that. The ramp is 1.5 meters high. So what the ramp is doing is actually raising that object up for you. Instead of you having to lift it directly up, it's raising it up for you, that 1.5 meters, but you have to input 5 meters of work. So you lift a given and unknowns here. The input distance, what you have to push the object along the ramp, that's 5 meters. The output distance, how far up does the ramp raise that object? It's 1.5 meters. So mechanical advantage is what we're looking for. Write the equation. In this case, mechanical advantage, we only need the distance parts of the mechanical advantage equation, which is input distance divided by output distance. So insert the known values. You push the object 5 meters, the ramp raises it up 1.5